Hello good people, I'm going to talk about the pH scale. The scale was developed by the Danish biochemist Søren Sørensen. Although this scale is now used across many fields of science, its initial development had to do with beer. Søren was working for the Carlsberg Brewing Company, and the pH scale was developed to help with the production of better tasting beer with consistent flavor. This is why chemists are popular at all the best parties. At this stage you might be thinking, well, that was an interesting story, but what does the scale represent? In short, the scale goes from 0 to 14, where 7 represents a neutral solution. A pH less than 7 indicates an acid, whereas a pH greater than 7 indicates a base. Great, but how do we get to these numbers? How do we get the pH values? For that, we need a bit of mathematics. The pH scale is a logarithmic conversion of the relatively small values for the hydrogen ion concentrations. The letter P in pH stands for Potenz, a German word for power or magnitude. In other words, when we express a pH value, we are expressing the concentration of hydrogen ions. To help us do that, we use the pH formula, which states that the pH value is equal to the negative log to base 10 of the hydrogen ion concentration. I'm going to use pure water as an example. Recall that the hydrogen ion concentration in pure water is 1 times 10 to the power of negative 7. I can substitute this value into my pH formula, and that will give me negative log to base 10 of 1 times 10 to the power of negative 7. While I know that most of you can do this calculation in your head, I'm going to use my trusty calculator. To perform the calculation, I'm going to enter negative, then the log button. Please note that the log button on your calculator is log to base 10, and then I'm going to enter the hydrogen ion concentration, 1 times 10 to the power of negative 7, and close the bracket. When I press the equal button, I get the pH value, 7. We can repeat this process for any hydrogen ion concentration. Note that as the hydrogen ion concentration increases, the pH value decreases. Conversely, as the hydrogen ion concentration decreases, the pH value increases. Before I finish this video, I would like to remind you of the water dissociation constant. Kw is the product of the hydrogen ion and hydroxide ion concentrations, and it has to equal 1 times 10 to the power of negative 14. This means that whenever we have the hydrogen ion concentration, we also have the hydroxide ion concentration. And here they are. Allow me to demonstrate. If we look at something like a solution of baking soda, which has a pH of approximately 9, that means that the hydrogen ion concentration is 1 times 10 to the negative 9, and the hydroxide ion concentration is 1 times 10 to the negative 5. If I multiply these two numbers, using my trusty calculator, I get the water dissociation constant, 1 times 10 to the negative 14. We would obtain the same result for any other matching pair of hydrogen and hydroxide ion concentrations. I will explore pH calculations in another video. For now, the key messages are that the pH scale goes from 0 to 14, where 7 indicates a neutral solution, everything less than 7 is acidic, and everything greater than 7 is basic. When we are expressing a pH value, we are in fact expressing the concentration of hydrogen ions. The greater the hydrogen ion concentration, the more acidic something is. That is all for now, and I will see you on the flip side.